This time, we will examine scatter plots for the bivariate Gumbel copula using different values of the theta parameter, starting from the smallest value of 1.1, followed by 1.8, 2.5, and finally theta equals 5. This will allow us to observe how the theta parameter helps model the dependence between the variables u1 and u2, and consequently between some real-world variables x1 and x2, which are represented by u1 and u2. When the theta parameter is 1.1, the scatter plot below shows that the points in the u1-u2 space are freely dispersed. There is no visible pattern or any distinctive arrangement of points that would indicate the presence of dependence. The points appear to be uniformly spread across the u1 to u2 plane. For theta equals 1.8, the scatter plot reveals that the points are no longer evenly distributed. Some regions of the plot appear more densely populated, while others contain fewer points. For example, in the upper left and lower right corners, we see areas with fewer points. Specifically, in the upper left corner, where u1 is close to 0 and u2 is near 1. Similarly, in the lower right region, where u1 is close to 1 and u2 is near 0. When the theta parameter is increased to 2.5, this phenomenon becomes even more pronounced. It is now clear that points are starting to concentrate along a positively sloped diagonal. In the upper right corner, we observe a higher density of points, while at the same time, large portions of the space remain almost empty. This confirms what we discussed earlier. There are substantial regions with very few or no points. Finally, when the theta parameter reaches 5, we see an even stronger concentration of points along the positively sloped diagonal. This highlights the core property of the Gumbel copula, its ability to model dependence in the upper tails of the u1 and u2 variables, and consequently x1 and x2. In the upper right corner of the scatter plot, the points are highly concentrated, almost overlapping. This suggests that when theta equals 5, the copula is capable of effectively modeling a relatively strong correlation between variables at high values. If such a strong correlation were present in real data, a scatter plot of those variables would likely resemble the one we see here, with very high point density in the upper right corner.